For millennia, these hand configurations were categorized as spiritual mysticism, but human neuroanatomy suggests a different, mechanical function. These postures act as physical triggers for systemic biological changes. Documentation of these physical states dates back to the Indus Valley Civilization. Artifacts like the Pashupati seal record specific, deliberate arm and hand postures that were later preserved in Vedic and Tantric texts. To understand why these gestures are effective, we look to the cortical homunculus, a map of how the brain perceives the body. While the hands account for only 2% of your total surface area, they command over 30% of the primary somatosensory cortex. This disproportion exists because the hands are high-bandwidth sensory arrays. The human fingertips pack a density of 2,500 mechanoreceptors into every square centimeter of skin. By locking the hands into specific geometries, mudras exploit this receptor array. They function as bottom-up neuromodulators, sending constant streams of sensory data to specific cortical regions. Clinical neuroscience can now map these somatic inputs. Utilizing high-density EEG and functional MRI, researchers can track the specific neuroelectric outputs generated by these ancient physical configurations. Decoding mudras requires analyzing them not as spiritual symbols, but as a system of biometric modulation. The process begins at the skin surface. That density of 2,500 receptors per square centimeter creates a high-resolution intake for mechanical data. Mechanical input is filtered by receptor type. Meissner's corpuscles near the surface process light touch. Deep, sustained pressure, forcing fingertips together, activates deeper Pacinian corpuscles. Conversely, open hand gestures stretch the skin laterally, triggering Ruffini endings. These receptors convert physical pressure into electrical signals, which travel up the spinal cord to the medulla. From there, the signal hits the ventral posterolateral nucleus of the thalamus, the brain's central relay station. The thalamus routes this tactile data into the primary somatosensory cortex, specifically mapping to Brodmann areas 3A, 3B, 1, and 2. Locking hands into a static posture prevents receptor resetting. This creates a continuous sensory gate, forcing the brain to process an unyielding data stream. Consider Jnana Mudra, which connects the tip of the index finger to the thumb while keeping the other 3 digits straight. The physical convergence of the index and thumb activates a neural convergence zone in the parietal lobe, specifically Brodmann areas 3B and 1. Quantitative EEG data shows this drives a 40% increase in frontal alpha power, associated with calm, focused attention. This state upregulates cholinergic pathways, which assist in memory consolidation and activate the default mode network. In Chinmaya Mudra, the thumb and index maintain contact, but the remaining 3 digits curl tightly into the palm. Folding those 3 digits engages the flexor digitorum superficialis muscle, changing the mechanical tension in the forearm. This muscular tension sends proprioceptive feedback specifically to Brodmann area 3A, a distinct target from the previous posture. This shift increases vagal tone, which influences the enteric nervous system in the gut. EEG readouts show the brain exiting the alpha state and moving into beta 1 alertness. Shifting 3 fingers a few inches triggers a transition from a state of internal reflection to one of external vigilance. The system extends beyond the hands to the cranial nerves, as seen in Shambhavi Mudra, an ocular-focused posture. The practitioner maintains a sustained upward and inward gaze directed toward the glabella, or the space between the eyebrows. This eye movement engages the superior colliculus and the frontal eye field. This specific cranial tension encourages parasympathetic dominance, lowering the heart rate and stabilizing the autonomic nervous system. The result is high-level gamma-wave synchronization, a state often measured during hyperconscious cognitive processing. Conversely, Bhairavi Mudra involves resting open palms passively in the lap. By providing no mechanical resistance or active pressure, this posture reduces activity in the primary motor cortex. This lack of motor output triggers thalamic de-arousal, essentially quieting the brain's sensory gateway. This forces the brain into delta wave states, typically measuring below 4 Hz, a frequency usually reserved for deep slow-wave sleep. This state correlates with the release of endogenous opioids, which can produce a measurable analgesic effect. These techniques function as neurological breaks, capable of inducing sleep-level brain states while the practitioner remains awake. These short-term shifts are temporary, but sustained practice relies on the principle of Hebbian learning. Neurons that fire together, wire together. MRI studies show that 6 months of practice correlates with a 5 to 8% increase in the thickness of the sensory motor cortex and gray matter density in the insula. This is accompanied by increased white matter integrity in the corticospinal tract, improving the speed and efficiency of the brain's internal wiring. For cortical remapping, the regions of the brain representing the fingers expand their territory to accommodate the increased data flow. These measurable changes in cortical thickness and white matter integrity suggest that mudra practice acts as a physical stimulus for long-term structural modification. These structural insights are now being integrated into clinical medicine. Dopaminergic mudras like Prithvi and Vayu are used to target deficits in the basal ganglia associated with Parkinson's disease. Vajra and Rudra mudras are employed in post-stroke rehabilitation to stimulate motor cortex reorganization. This clinical efficacy bridges ancient elemental mapping with modern neurochemistry. This matrix shows how traditional digit-element pairings correspond to the sequential arrangement of the somatosensory cortex. For example, the thumb, associated with the fire element, correlates to the dense sensory receptors of Brodmann area 3B. The index finger, or air, maps directly to area 1. Functional MRI studies demonstrate that these finger placements generate bold signal increases of up to 60%